Previously in this class, we talked about the basic principles of object-oriented programming in Java. We did this with a simple blackjack game and card class. This showed how objects have instance variables which define the data that the objects contain, and objects are created from a class which serve as its data type. The classes have methods, member functions, that are defined on them, which really result in defining the behavior for those objects. Now we want to switch our paradigm a little bit to talk about different capabilities of classes that are unique to object-oriented languages. Those capabilities are called inheritance and composition. So for this domain, we're going to switch to a simple graphics shapes domain where we have circles, squares, rectangles, lines, and those types of objects. And when we start out, we'll simply have a text-based output where these shapes will draw themselves by merely sending text to the console. This will allow us to keep our examples simple and build on these capabilities one element at a time. So we start off with a class called point, and I've switched back to the JGrasp IDE environment from Eclipse because it's simpler and it's easy to demonstrate some of the class relationships that we're going to build here. So by a point, we mean a point on a Cartesian coordinate system. It's two-dimensional and it has an x and a y coordinate. We make those simple integers that are private data objects inside point objects. Here's a constructor on class point being on line 11, and the body of the constructor simply takes the two formal parameters passed in and assign them to these instance variables inside each point object. Then lastly, we've implemented a toString method, and this is the method that will be called whenever the point is needed to be rendered as a string. For instance, printing them out using system.out.print or print line. Next, we'll take a look at a class called line, and this will be our first use of inheritance. We use the keyword extends in Java to invoke inheritance. So now we say class line extends point. Now what that means is that class line starts off with everything that's already defined on point and then can add to that definition. So a line will have private instance variables named x and y already because they're there in its parent class point, and it can also use some of the behavior. For instance, it might be able to invoke the constructor if it needs, or implement toString and invoke toString if it needs. So this is a simple idea of inheritance where line is going to start off not from scratch but start with a basis of everything in class point. Then we add another private instance variable to a line called endpoint. Because a point already has an x and y starting coordinate, that'll be the start point of the line. We'll have another point object here called endpoint, ENDPT, which will hold the x and y coordinates of the end of the line. Now, this is an explicit object created as an instance variable inside a line here on 24, and this is called composition. Composition is simply the idea of having a sub-object. You create an instance variable that is an object inside your own class, your new class. So when we go to construct a line, we actually have 4 points that we need to set. We get 4 pieces of data. x1 and y1 will be the x and y coordinates of the first point, and then x2 and y2 will be the coordinates of the second point. Now, here on line 28, we have to first initialize the point sub-object that's contained in every line. So in order to do that, our constructor for line on line 28 needs to invoke the constructor on line 11 and its parent to initialize that first inherited point. So in order to do this, there's a super keyword in Java that can be invoked as a function. Super is a constructor call to your parent. inheritance, a class can have a parent, and when it invokes its parent's constructor, it does so in this manner using the super function. So we simply pass super the 2 point data x1 and y1, and that will invoke the constructor on that first starting point subobject using the constructor here on line 11. That's half the job. On line 29 we do the rest of the job, which is to take the other 2 point data, x2 and y2, and initialize the endpoint object, which we hold by composition in our line objects. So that's simply done here on line 29. We call the new constructor on class point, passing it x2 and y2, and now we've initialized the endpoint instance variable. Scrolling down here to finish off class line, we see that it also has a toString method, and it's going to take advantage of the inherited toString method in its parent class. So on line 34, whenever we wish to print a line, the first thing we do is print out the characters line from, and then we invoke the toString method defined on our parent class in class point. So here we use the super keyword as an object. We say super.toString, send our super class the toString method, and that invokes the method up here on line 17 on that point subobject that we inherited. So the first thing that prints is the point initialized with the x1 and y1 data prints out its representation in a set of parentheses with a comma separating the x and the y data points. That's all done by the call to the superclass's toString method. Then we output the string 2, and then we output our endpoint. By placing endpoint here, endpoint is of type point. That simply invokes the toString on class point once again with new data. So whenever we print out a line, we ought to point out that the toString method in line piggybacks on the toString method in its parent class point. Scrolling down a bit further in this file, I wish to point out that we have another class called text shapes, which is going to contain the main method that we'll use to run and test our other two classes. So I've commented out some of the other code that we'll build on in a moment, but basically what we want to do is create a point at the origin, 0, 0, and then create a line. We'll call it line 1, and then we wish to print out the point to show that the points toString method is working, and then we wish to point out the line to show that the line's toString method works and it piggybacks on the toString method in its parent class point in doing its work. So if all of this works out fine, we should be able to see the origin printing itself out at point 0, 0, and then line 1 printing itself out starting at point 1, 1 and ending at point 2, 2. So let's go ahead and run that and see how this comes out. And we see the first line of output here shows point 0, 0. That's our origin printing itself out. From line 108, printing the origin has resulted in this first line of output. And then line 1 prints itself out, a line from point 1, 1 to point 2, 2. And so we can see that the piggyback behavior of the toString methods does indeed work. Scrolling back up in the file to take a look at our original class code, we see that both inheritance and composition result in sub-objects being created in our class that we can create other objects from. The inheritance puts sub-objects there very subtly through the fact that class line, in this case, builds upon class point. It inherits that private X and Y data and the ability to invoke the methods in its parent class. Through the super keyword, we can either invoke super as a function to call a constructor like we do here on line 28, or use super as an object to invoke one of the other methods other than the constructor like we do here on line 34. That's all part of inheritance. Then composition, which is a much simpler concept, says that we just create an instance variable from another class. So we have a subobject. This subobject is called endpoint, and it's of type point. And we can send messages to the endpoint object if we wish to invoke behaviors on it. So both inheritance and composition lead to having subobjects in your class. The inheritance is a bit more subtle because the subobject doesn't have a name. There's no handle or name that we can grab onto to send it a message, but we can use other methods like super to manipulate its elements, and composition, which does give a name to the subobject. Here, endpoint is the name of the other point object that makes up the endpoint of the line.